Our class for marine science is very fortunate. We had this opportunity to come have a field experience. How often do the students get to go from the 4 cement walls out into public because of the influence of businesses around as well as the naturalists and scientists?
What are the 2 sources of pollution? What are 2 sources? Okay, point source pollution. Point source pollution comes from a specific source. You can point your finger at that type of pollution. An oil spill, that's a great example of point source pollution, but there's other kinds too. Anytime you have a factory or a sewage treatment plant that is leaking and you know where it's coming from, that's point source pollution. The other is non-point source pollution, and for us, that is probably the biggest problem with pollution in Florida. Anything on the land, on the watershed, picks up anything there and it's going to take it into that body of water. We don't know where it's coming from, so it's very difficult to take care of. So those are the 2 sources of pollution, and when we test today, we're going to be looking at some of the specific types of pollution. So the first thing I want you to do is we're going to take our temperature reading. Okay, would you record that? And of course, it's really important when you write your numbers down to put your units, and this is in degrees Celsius. Now, temperature is very important because the amount of oxygen that is dissolved in the water is very much affected by temperature, and we're going to look at that in a minute. So the next test that we're going to do is the dissolved oxygen test. What we're going to do is I'm going to have you take your little test tube, this one, okay, and you are going to put it into your sample jar at an angle like this, and while it's underwater, you're going to bring it upright. Basically what you're doing is removing any bubbles. You're just going to invert it like this, and this test takes a while. So what we're going to have to do is somebody who's doing this is going to have to actually do this for about 5 minutes and until it's dissolved. But once it's dissolved, you can just lay it sideways into your the lid, okay? Because we're going to go on. So we're going to look at 2 nutrients today that are found in fertilizers. One is nitrogen, and we're going to test for nitrate, and the other is phosphate. So the first one we're going to do is phosphate. So I want you to get your larger tube, this one, and if you look near the top, there's a line that says 10 ml, 10 milliliters. So you're going to fill that up to the 10 ml line. And this time you're only going to get one of the chemicals. Now once you put that chemical in, you will be putting the lid right on. Now again, the phosphate takes time to dissolve as well as to develop, so we're actually going to go on to another test. This is one of the plant nutrients. The other one we're going to do is nitrate. After you put the nitrate tablet in, you're going to go ahead and put the top back on. And again, these take a while to develop. So we're going to go on to the next one, and we're looking at turbidity. It is the clarity of the water. So the color of the water does not affect their turbidity. You can have very clear water. In some areas out east where you have a lot of tannin in the water, the water will look dark, but it still can be clear. The way we test for the clarity of the water is looking at the little circle at the bottom of your jar. Take a look. Believe it or not, that is a Secchi dish. And basically what it is, it's so simple, it's just looking at black and white, the alternating black and white colors. This is your card that's going to tell you your results. So you find the side that has turbidity. And all you're going to do is hold it up next to it, and you're going to put a range of 0 to 100 JTUs, which stands for Jackson Turbidity Units. We're going to do another test, pH. You know, whether the water sample is either basic or acidic. So the scale goes from what to what?
0 to 14.
0 to 14, and what's in the middle?
7.
7, which is neutral, right. Now, where do you think the pH of the water should be healthy for aquatic organisms? It's somewhere around 7. The best way to do it is to hold it up like this. And then you can get a really good idea of what the number would be, the pH. I believe that we can go ahead and look at our dissolved oxygen. Find your temperature of the water, then you're going to go over and you're going to, if you got 0, you write that number %, or if you got 4, that one, or 8, this one. There's 3 different colors, and what you're doing, again, you're looking at how deep the color is. If it's no color at all, it's 0. If it's kind of a lightish color, it's 4. If it's a nice dark color, it's going to be 8. Now we've done dissolved oxygen, we've looked in parts per million, and we measured in % saturation. Again, very important. The next thing I want you to do is you've done your pH, so we can put that aside. I want you the phosphate one, and it should have a bluish color. Okay, again, hold it up next to your chart so you can get a really good idea. And again, you can put anywhere from 1 to 4. You don't have to put the exact number. If you think it's between 2, that's fine. All right, the next thing we're going to do is the last one, which is nitrate. Now, if it is yellow or clear, there's no nitrates. You put 0. If it has a pinkish color, then you do put one of the numbers. All right, now let's look at our results. If we average their 80s with your 40s, we're going to get what? 60s. And so that is ample amount of oxygen in the water. Again, where I collected the sample could make a difference. If I went further out, over by the seagrasses, or even deeper, it could have been different. How about phosphate? Look at your phosphate reading. So if you got a phosphate reading of right around 1 or less, that is excellent. Okay, and how about pH? Did anybody get a pH of 7 right on the nose? Of course, that's excellent. How about between 6 and 8? That's good. Okay, so and I think so the pH is fine. So based on what you can see right now, again, this is just our testing today at this very point, what would you say about the health of the water at Emerson Point? It's good, good. So that's really good news.
It's a lot more fun than a video game. It's real world.